Welcome to the Glassworking shop. Well, the resizing operation came out really good, and I took a still photograph of what the pieces look like, and they're pretty good. They're not perfect. I think I see a few little holes, a few little air bubbles, but I can't seem to get rid of those guys. So next step in the operation is to go out to the cold shop, and boy, it's cold out today in the rain in Northern California winter, but I'm going to go out in the cold shop and slice up these pieces and then prepare them for fusing in my experimental Chip Stack Kiln Rig. So move the camera and let's get started. So I'm out at the wet saw here, and I've got the fence set up to make a almost 1/4 inch. Let me get some of the trash out of here. Make an almost 1/4 inch slice. And like I said before, the reason that I make the slices so thick is so I have a little bit of extra to be able to grind away and kind of like get rid of some of the scuzz on the surface that's produced when these things are fused together. I've also got a kind of a wood backing block here because I don't want the blade to run into the aluminum part, and I'm going to have something that the blade can kind of get into. So turn on the water. I've been thinking about possibly using a hot water recirculating system with a heater and a pump. Right now I'm just using tap water, and it is really cold. Boy, oh boy, I tell you. So here we go. Trying to be very careful at the end of the cut to really reduce the pressure and exit the cut very slowly to avoid chip out. And even when I'm careful, I sometimes get a chip out, but oh well. Now, once the chips are cut, I'm putting them into a little plastic box that you can't see on camera, and I'm putting them in the order and orientation they were cut. Because when I assemble these things, I use a technique borrowed from veneering called book matching to try to get the patterns to line up really well at the edges where they meet. So I think I'm gonna dress the wheel here. It seems to be cutting a little slowly. So the resizing operation produces a very uniform square with very straight sides and very sharp corners. Not perfect, it's not like CNC machine shop perfect, but for glasswork, it's way better than I could have ever pulled. I think even if I was a skillful puller, I think trying to get it this good in a hot pull is probably impossible. But resizing with the squeezer makes it pretty easy. So I'm going to probably stop talking here and just speed up the video because it's a lot of repetition. get another slice out of it? I don't know. This weird end here, I don't know, it might be fun. Maybe I'll polish it up. Not sure I can get another slice out of it, but I'll just put it on the bench. And the pattern is starting to get kind of crappy looking. Maybe one more slice. That's the annoying thing about marine making. The ends are never quite as good as the middle. I think that's true even for the more experienced workers. Yeah, I think that may be it. So next, gonna go back into the hot shop, assemble them on a ceramic plate, put them in the kiln, heat them up, and stick them together. So, see you later. Okay, chips are all cut, and as you can see in the still photo, I've got them all lined up in the order and orientation that they were cut, so that I can take them off and book match them to try to make the patterns line up as accurately as I can. So I'm going to be putting them on the 99% alumina ceramic plate that so far has produced the best results for me. Just to review a little bit of the history of this, I've tried various different steel plates. I've tried mild steel, I tried stainless steel. The mild steel ended up, as any blacksmith knows, forming an oxide crust and a scale that really interfered with the glasswork. Also, if the steel gets red hot, the chips stick to it. The stainless worked a little bit better. It didn't produce the same scale, but had the same red hot sticking problem, and over time it tended to warp. Then I switched to a graphite plate in my old process before I got the higher temperature kiln, and the graphite plate worked, but graphite is an organic material, and it burns in an oxygen atmosphere. In an inert atmosphere, it'll take up to 3,000 degrees, but in an oxygen atmosphere, graphite burns. One of the first experiments I tried in this kiln rig was to put a piece of graphite in, and when it came out, it was red hot, and I could obviously see that it was burning. So then I started experimenting with a variety of different ceramic materials, and the first thing I tried was regular kind of kiln shelf ceramic, and it kind of worked, but the chips stuck to the plate if I got them too hot, and the material, it kind of wasn't really that good. I tried Kiln Wash, which was suggested by a lot of people, and the Kiln Wash worked, but it left a kind of a dust on the surface that flaked off and got embedded in my chips and made for even more cold working trying to get it off, and some of it got embedded quite deeply, which was really unfortunate and kind of a pain. Then I started looking around in the ceramic world and discovered that very little high temperature ceramic is available off the shelf at reasonable prices. Almost all of the ceramic suppliers said, please contact our engineering staff for a quote on your custom project. And yes, I have contacted at least one supplier for a quote on my custom project, and I'm still waiting for an answer. I did find some material from 3 different sources. I found some from McMaster Carr at what appeared to be outrageously high price, which is the one I'm using now. I found one on another industrial site that was in stock for reasonably quick delivery. And then I found one on eBay coming from China. The one from the industrial site kind of looked pretty good. It was dense. It appeared to have a nice surface, but it cracked immediately on first use. The Chinese one is still sitting on my bench. I haven't tried it yet. I'm going to kind of go with what I know, go with what I've had success with, and use the 99% alumina from McMaster Carr. And what I've discovered in this process is that, first of all, if I tried to just put it in the kiln, run the kiln up to 2400 degrees, and get it all to stick together, well, the chips would stick to the plate. And I don't know an answer for this. I'm still experimenting, still searching, but who knows? It may just be that that's the nature of glasswork. And maybe the people that do things like cast telescope mirrors out of Boron very possibly just have the mold be sacrificial and then just chip away the mold when they're done. But I haven't fully researched that. There's a lot to learn about this, especially if I'm doing it on my own with only the Google to guide me. If anybody out there in YouTube land knows the answer, please educate me. I love learning. So anyway, I tried using boron nitride release spray on the ceramic plate, and it just flaked off immediately as soon as it got hit with the torch. It's probably okay for soft glass fusing where the pieces are not disturbed, but for the Boron with the torch work and the paddle work that I'm doing, it flaked off immediately. I haven't tried just high temperature fusing with boron nitride protecting the plate. I might try that later, but for today's video I'm going to go with what I know and do the hand torch fusing using the graphite tools and kind of using the kiln as a preheater to get it somewhat close. What I discovered as far as temperature goes, in my experiments, I've tried a variety of temperatures. I tried 2000, I tried 1800, I tried 1700. And if I set the kiln for 1700 and leave the chips in for a really long time to let them like totally get up to temperature, they stick to the ceramic. If I set the kiln for 1500, which is just barely below the softening temperature of Boron, I can leave them in as long as I want and they won't stick. And then they're kind of preheated to almost soft state. And that way when I take them out and hit them with a hand torch, the hand torch only has to bring them up just a little bit to get them soft enough to stick together. So that's the plan for today. Set the kiln for 1500 degrees, preheat the chips for a fairly long time, and then take them out, hit them with the hand torch, squeeze them together, try my best not to overheat the surface, change the set point on the kiln to 2000 degrees so that the kiln has a chance to recover a little bit better while I'm working outside the kiln. The kiln will be heating up to a higher temperature. And for some odd reason, the controller kind of went into an error state before when I was putting a cold plate into the kiln with the set point set at 1700. When I put the set point up to 2000, the software does not see that as an error when the cold plate goes in and the temperature drops down below 1500, and the controller seems perfectly happy with that. So I'm going to go get some chips. So this operation is kind of borrowed from veneering. It's called book matching, and that is where you unfold the pieces like they were pages on a book to, let me wipe off some of the water on this. I've read comments from people who say that it's a good idea to not use them right off the saw, to put them in the ultrasonic. I haven't been doing that. Maybe I'll try that someday. Anyway, it looks like I've got a few small air pockets, a few small defects, a few small holes. I'm starting with the less good chips for this version, and then as I practice, I'll be able to move to the primo chips, which are in the center of the pull. These chips are kind of from the end of the pull, and that way, if something goes wrong, and I'm not going to be wasting the best of my best chips. So, got the pieces arranged. The pattern looks really nice. I'm optimistic that I'm going to have success. The mechanism is working really well. The sliding mechanism, the little kind of like forklifty thing, the kiln top lifter, all the mechanism is working really well. The problems that I'm facing now really just have to do with time and temperature and substrate and trying to get the glass nut to stick. So this controller seems to take forever to boot up. I don't know what it's doing in there. So here we go. Kiln is preheating. I'm gonna go away for a while. This heating process, unfortunately, this kiln heats very slowly. It's a kind of an underpowered little baby kiln, and it heats really slowly, it recovers really slowly, and who knows, as I evolve this process, I may attempt to upgrade it, maybe replace it, maybe design something myself, maybe, who knows, I don't know, it's all R&D. So anyway, I'm going to turn the camera off, and then when I come back, it'll be time to stick them together. Okay, the kiln is up to temperature. It's been sitting there heating up and soaking for about an hour and a half, and I think I'm ready. Let's see if I can make this pig oink. This process, I've been having success with it, but I've also had surprising failure. I've also had times when I thought, oh yeah, I've got this, and then I go to do it again and something goes wrong. So it's all a learning experience, it's all R&D, and if anybody out there in YouTube land has this process mastered, please help me out. Give me some hints, give me some clues. But as far as I've been able to research, just looking into it in the limited way I do, I haven't yet found a master of this technique. Of course, that may mean several things. It may mean that I'm just not that good at finding things. It may be that not that many people do it. It may be that the few that do it want to keep secrets. It may be that it's just a stupid idea and everybody that's tried it fails. Who knows? But anyway, here goes. I'm using a Mirage hand torch. And I'm setting a kind of a gentle flame. I don't want the flame to be too aggressive, and that's part of the trick I'm trying to work on here, is to figure out exactly what kind of flame to use. And also got a Smith mini torch with one of those 7-hole aftermarket tips that I'm experimenting with. And so first step is just to try to get the chips to stick together. They're looking nice. Everything is looking good. Trying to get them to stick together and not stick to the plate. The fit is excellent. There's almost no gaps to fill at all. It is not sticking to the plate. I believe I have them somewhat tagged together. Now I'm just concentrating my heat on the places where they meet. Because when I squeeze, I want to squeeze together the mating edges without excessively distorting the inner pattern. And of course, as I'm doing this, I'm trying to be oh so careful to avoid overheating the surface, because bubbles are my nemesis, and I'm working so hard to try to get rid of the bubbles in my design. So that is actually looking pretty darn good. I'm going to switch to the larger flame here and just kind of, I don't want to get too much unevenness in heat. If I concentrate on the center joints while letting the piece get cold, I may end up with some thermal problems. And so even though I'm mostly working on the joints, I still like to occasionally kind of give it an overall heat. Gonna see if the little hand torch can help out any here. Yes, I am getting some very nice melting action going here. Closing up the few little gaps that I have. I made a little spudger tool out of graphite to kind of really gently apply a little pressure. Of course, the downside to this tool is that it puts divots in the piece that take a lot of work to remove. And so I would prefer, oh, look at that, I closed up the center just beautifully, melted it all together. This little mini torch might be a really good tool for this. Of course, I do have, That's kind of an unpleasant little thing that I'm seeing in the pattern. Hope it's only on the surface and not too horribly deep. Now the little mini torch seems to be working really well, but like I said, you've got to be very careful to not just concentrate so much on my localized heating that I'm letting the piece get cold. I wonder what that, got a kind of a weird dark line there I'm not happy with. This may, I'm using the end chips, and I don't know, I may have a problem here, but if nothing else, I get some practice out of it. I've also got a couple of little air pockets that I need to close up, and of course that's the real trick in this process. If I'm trying to close up an air bubble, the tendency when I'm focusing the heat on the air bubble, the tendency is to overheat things. And boy, I'm trying so hard just to be gentle. The piece is getting very soft. So I need to really concentrate on being gentle with this. And of course, that's the challenge with this process, that even when I'm thinking about being gentle and talking about being gentle, sometimes I'm too rough. So it's always a question of how much force to use, how much flame to use. This is definitely, without a doubt, a process that requires finesse and technique, and there is so much to learn and so much to work on. But all that being said, it's also looking really good. Part of the key to success here the more accurate the chips are before starting the process, the less work I have to do to fill the holes and fill the gaps and get everything to fuse together. And I can get that little air pocket under control. As all glassworkers know, I I don't think everybody knows this, but it's fairly common knowledge among glass workers. There's a big difference between the softening temperature and the melting temperature. And when I'm trying to take care of the air bubbles and close up the gaps, I need to get it very close to melting temperature. That popped a little bubble. Of course, the challenge with this process is that if I'm trying to pop one bubble in one place, if I don't get the heat right, I may pop my target bubble, but then I introduce another bubble kind of in a different place because I'm being too aggressive with the heat. And of course, for me, trying to transfer some of my skills from work I've done in the past, trying to get an intuition for how heat moves through glass is really hard, because glass is an insulator, and everything seems to go a lot slower than I would have expected, even when I'm expecting it's going to go slow. And so I'm still getting used to just working way, way, way slower than I'd like it to be. In welding, things happen right away, especially TIG welding. You hit something with a torch and boom, you got a puddle. And the timing is completely different. But glasswork, it is slow. And I have to kind of readjust. I mean, it almost looks like nothing is happening. And when I first started doing glasswork, I was kind of mystified. Wow, I'm heating and heating and heating and heating and nothing is happening. And as I started recalibrating my eyeballs in my brain, I started realizing, yeah, it's happening, but it's like watching the minute hand on a watch. It's happening really, 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 really slowly. So I'm going to go over here and reset the controller to the higher temperature setting, set it to a set point of 2000 degrees, even though I'm not going to let it get to 2000 while there's glass in it, because I made that mistake once and it stuck like glue. I mean, I had to destroy the glass piece to get it off, and it destroyed the ceramic getting it off, and it was just a terrible, unrecoverable failure, which is another term from space exploration that I've learned, and one of my least favorite things is unrecoverable failure. So I changed the set point to 2000 so that when the piece is out of the kiln can recover to a fairly nice higher temperature. I take the piece out of the kiln when it gets to like 1500, then while I'm working, the kiln recovers to roughly 1750 or something like that on its way to 2000. When I put the piece back in after working on it for a little while, the kiln drops down to like 1525 or so, and that means that it takes a little bit less time for it to recover to 1550, which is 1550, 1600 or so when I take it back out again. And so what I've learned with the experience that I'm developing while doing this, that if I have the piece that has been sitting out in the cold air for a while, and yes, it is pretty cold out here in the Northern California winter in December, when I take the piece out, the plate is rapidly losing heat, And so even though I'm putting the piece into a 1700 degree kiln, it still takes a while for everything to come up to heat. And of course, the top surface of the glass, the part that I'm trying to work on, is the part that gets hot faster, and the critical area in between, the critical area where the glass meets the ceramic, it takes the longest time to heat because the ceramic is heating from the bottom up, the glass is heating from the top down, and this is very much like what the glory hole guys have been telling me about how they do this work in a glory hole, primarily soft glass, that you put it into a really hot hole and it heats the top of the glass, and then you use your judgment to get it out before it has time to stick to the ceramic. So we're at 1350. It's going to take a little while to get up to 1550, so camera off. See you later. Okay, back again. See if we can get the bottom side, or the second side. I don't know which one is the good side. Possibly the side I worked on first was going to be the less good side. No, love that. Love that Mirage hand torch. Okay, here we go. No sticking, which is a very, very, very good thing to see. Got a few holes. The joint where the pieces meet is very nearly perfect, which is the nice thing about the resizing process that I showed in the last video. It's much easier to assemble chips when they are very close to correctly sized. So, I'm still experimenting, trying to figure out when to use the little baby torch. When to use the spudger. How far to keep it away from the glass. Okay, well that corrected that little air bubble. Once again, like I said, getting that surface up to melting temperature does not go quickly. Boy, there is a lot of skill and finesse that I need to learn and perfect to be able to concentrate heat on a bubble to get it to close up without overheating the surrounding material. There is no way that this is easy. And then, of course, as I said before, I'm trying to avoid fixating At one time in my past, I was a pilot, and one thing that you learn in flight school is to do an instrument scan to avoid fixating on one thing. So if all you do is look at altitude and you don't realize that your heading is wrong, or that your fuel is low, or that some other problem, you're off the VOR, and you're just totally focusing on altitude, or you don't check outside to see if there's traffic, you got to develop a scan where you look here, then look there, then look here, then look there. And I find this to be so relevant to glass that typically when I have a catastrophic unrecoverable failure, it's because I'm totally focusing on one thing and not realizing that my piece is getting cold, my moil is getting cold, I'm only working on one side and the other side is getting cold, and I end up with a crack, an explosion, falls off the punty. So definitely it's very important in glasswork to maintain the equivalent of a pilot's scan. So I'm using two techniques to try to fill up this hole. I'm pressing slightly with the spudger and concentrating heat with the mini torch, and trying oh so hard not to overheat the surface and boil it, but you know, it may be a futile quest. I think I got that one closed up. Well, there's another one. It goes so slowly, it looks like nothing is happening, nothing is happening, nothing is happening. But I think, in fact, something is happening. Just really, really, really slow. Got that one closed up. That sound in the background is my oxygen system starting up. I think I'm having fairly good success with this little mini torch, but of course I can't fixate. Got to do a little bit of mini torch work, re-equalize the surface, and of course every time I use the spudger I introduce a bit of a divot, so I need to go back with this paddle. This is a specially designed custom paddle that I made that has a welded steel reinforcement on the top, so I can apply a substantial amount of downward pressure, which is something I would never want to try with a regular graphite paddle that's just attached with some screws in the end of the graphite. That'd break the paddle butt good. Of course, during this operation, at this point in the process, the glass is really soft, which is good. I like it to be soft. And it's part of the reason that I designed this apparatus, is to be able to get the glass overall hotter and softer. In my initial experiments, I was overheating the surface with the body of the glass not quite hot enough because I was on graphite, and I started from colder glass before I started applying the hand torch. So with this process, the substrate is hotter, the glass is hotter, the heat is more uniform. Okay, let's go back on bubble patrol. Of course, what I gotta be careful of I don't want to introduce 10 new bubbles trying to get rid of one old bubble. And of course, that is always a possibility. It also depends a lot on what color I'm working with. Some of the colors in this pattern are much, much more sensitive than others. And when I try to fill in a bubble, I end up with a great danger of introducing more bubbles than I fix. The outside edges, definitely the more difficult part. Okay, that's probably enough. I'm gonna put it back into the kiln for a bit of a reheat. And go back here and take a look. 1700, 1690, temperature dropping. Get those torches turned off. (1611, 1608, 1590, and usually stabilizes after this amount of time with the plate being out in the cold. It usually stabilizes somewhere over 1500, but let's find out. 1550. $15.20. The rate of fall in temperature seems to be slowing. We haven't stabilized yet. 1513. And looks like we're probably going to dip under 1500 because it's still falling, approaching 1500. So, like I've been saying all along in this series of videos. This is a work in progress. It's an experiment. I suspect it's a valid experiment to perform. I don't believe that success is guaranteed, but so far I'm having at least partial success. Nothing is ever perfect, and I wonder how far I can perfect it as I continue to develop my skill and improve the quality of the equipment. I know that the Boron glory hole guys, or actually I only know one guy that has a Boron glory hole. The Boron glory hole is over 3,000 degrees, and the trick there is, of course, stick it in, leave it in for exactly the right amount of time to get it exactly the right temperature, take it out and work with it. I'm not sure that it would be reasonable for me. You can see this is, I'm space limited in this shop. I don't have a lot of space in my shop in general, and of course I have a full machine shop, an assembly area, and an electronic shop, computer shop. There just isn't a lot of work, a lot of room out here, so I don't think that I could put in a full-size Boron glory hole. Could I make a mini one? Maybe about that big around? I don't know, maybe. Could I design a better electric kiln? I don't know, maybe. Could I contact a kiln maker and say, hey guys, you make any customs? I don't know, maybe. Could I keep using this one? I don't know, maybe. Anyway, 1508. Temperature is on the rise again. 09, so it dipped slightly below 1500. It's kind of heading back toward the usable range, and while I'm waiting, I'm just gonna say one more thing. I've said this over and over and over again. I'm probably sounding a little repetitive when I keep saying this, but probably an important thing to say, that, you know, some might ask, well, dude, you're not a master. What are you doing making videos? You should leave the videos to the masters. Well, yeah, I'm not a master. I am what I am. Don't even want to label it. I'm on an adventure. I'm sharing my adventure. I'm showing what I know. I'm a tool maker. I'm an inventor. And by showing how the tools I make can be used, maybe somebody who's interested in buying an Inquala will watch my video and maybe be thinking, oh, he's not a very good glass worker, is he? But hey, I like that tool. So, you know, I show what I know. Making videos is fun. Of course, my wife would probably say, why are you being so hard on yourself? You're really good, come on. And well, it's true of everything I've ever done, and every person I've ever talked to who has ever accomplished anything. Critical ability advances faster than the ability to do the work. You always think your work is crap no matter how good you are. And hey, I'm making progress. I'm getting better. So, the basic fusing is finished. The piece is stuck together. Most of the gaps are filled. A little bit of blue knob, just crack it a tiny bit. Okay, here we go. straight to the big torch. Piece is not sticking to the plate. What I'm doing now is concentrating on trying to get it as flat as I can. And of course, because I'm doing it by hand, it's really difficult to judge if I'm being totally parallel or introducing a kind of an angle to it, which is something I don't want to do. Uniform heating is hard. As soon as the torch moves away, the piece starts to cool. Also, when the torch hits the ceramic plate, it's stressing the plate, and I've started to notice a few small cracks appearing in the surface of the plate, which is something I never want to see. I still have a couple of little bubbles, and I'm not at all confident that I'm going to be able to get them out. So, I'm going to try one thing, and who knows, like I said, it's all R&D, and I may completely booger this up. I got one bubble that seems to be a bit of trouble. It still has a kind of a skin over the top, so I tried popping it with a tungsten pick, and sure enough, boy, that actually worked. I'm also imagining, as I wildly speculate on possibilities, also imagining if, well, would it be possible if I came up with, I don't know, a sacrificial mold or something like that? Would it be possible just to heat it to 2400 degrees and get it all to melt with a nice flat surface? Or would the surface tension of the glass just turn it into a big ball? Turn it into some bizarre marble shape? I think I need to do some research. I've been somewhat following the construction of the giant Magellan telescope at the University of Arizona mirror fabrication lab where they cast borosilicate glass, a large quantity, a giant quantity of borosilicate glass, and be interested to find out, does it stick to the mold? I suspect it does. I suspect it sticks to the mold, and then after, I think it takes like a year to anneal. After annealing, I think they just chip the mold away, but I need to find out for sure if they know something I don't know, if there is a casting material that could actually be used to completely liquefy the glass and get it to flow and not turn into a marble and not stick to the cavity. And anyway, reheating again. Probably going to do one more surface press, then move over to the bench torch, kind of set up operations at the bench torch, and see if I can refine. Remember I said that the outer edges where the glass chips fit together, right at the extreme outer edges, it's pretty much impossible to fuse those together on the plate because I'm overheating the plate at a spot, causing thermal shock and making the plate crack, and I'm also not getting the glass hot enough because it's right there where it's in contact with the plate. And so for finishing up the final edge geometry, I'm going to punty it up, take it over to put it in the Inquala, and use the little mini torch with the piece over a Bunsen, and see if I can kind of refine the edges with the piece on a punty. Of course, I got to be really, really, really careful with a large diameter or a large surface area square piece sitting on a punty, because boy oh boy, it wants to bend. Okay, looks like it recovered pretty quickly this time. Looks like my strategy of allowing the kiln to continue heating while I'm working, looks like that strategy is working very well. So I'm going to get back to the torch. I'm not going to use the little mini torch on this. This is the final surface refinement that will be done only with the Mirage. So out it comes. And I definitely have a problem on this side. This will not be the good side, which means that it's in a really good configuration with the bad side up, because I typically punty to the bad side. I'm going to do just a little bit more edge refinement here. Trying hard to keep it square by eye. The last one I did got a little bit out of square. It ended up being a tiny bit rectangular. So far the plate, the 99% alumina ceramic from McMaster is holding up very nicely. I do see some minor signs of cracking, and I'm definitely going to be looking for a lower price supplier. For those who don't use McMaster car, the good news is they have everything and they ship really fast. The bad news is it's always higher price, sometimes dramatically higher price. And I have no doubt that if I found a better supplier, I'd get a better price on this stuff. But it may simply be an industrial fact that exotic ceramic is expensive. That just may be the fact of life. So, got my quick disconnect fittings here. Gonna move over to the bench. Okay. There is a lot to do here, all at the same time, trying to manage the cameras, rearrange the cameras, deal with the bench torch, swap the torches over, get it all under control. So many things to do. So, got my pre-made punty with the tip already somewhat ready to go. I definitely do not want to apply pressure in the center when the center is hot. So there we have it. So what I'm going to do here, I'm going to set up the Bunsenizers. And see if I can maybe put the piece out in the outer flame for a moment. Get it somewhat back on center, somewhat uniformly heated. On the Bunsen, put the plate back in. I like to leave the plate in the kiln so it doesn't cool too quickly. I'm going to be using a little tweezer thing and a little, I think they call it a butter knife, and kind of still like keeping the big torch going, just it is nice to have it going, but don't need to be wasting a lot of oxygen. and I definitely want it out of my way. So I'm gonna put the Inquala into positioning mode. This is one of the great uses of the Inquala. One of its main features is to be able to have a piece held in place over a Bunsen, staying hot and happy, while you're working on it with a hand torch. And this can be for making assemblies, for perfecting welds, anything you want to do. And yes, this method does produce very good results. It's nearly impossible to melt these corners together doing it on the plate, but it's no problem at all to do it when it's on a punty under a Bunsen. Just boom, there it goes. Perfect weld. Of course it does, just by the nature of it, even though it's a perfect weld, it's still a low spot because there just wasn't enough glass there. And when you fill in an opening with glass from surrounding areas, well, you're going to make a low spot. So I'm evening it out a tiny bit with my graphite tool, but mostly I won't be able to even it out until I get over to the cold working, and then I'll just kind of grind it away a little bit, which is why I put that extra thick rim of black, so that I have a little bit of glass to work with as I'm grinding it away. Looking good. Because it's on a Bunsen, because it's above a Bunsen, I don't have to worry about it getting cold and falling off the punty, or at least I think I don't. I haven't had one fall off yet. Closing it up, and there we go. It is welded, and the weld looks very nice. I do like this little 7-hole tip. I don't remember whom. It might be a Blast Shield. I think it actually is from Blast Shield. But whoever made it, I like it. Well, I'm working a little bit of a side comment that's only kind of barely related to the topic I was discussing. I'm using a Smith hand torch, and a lot of people don't like Smith. A lot of people think they're really poorly made. But there's another company that makes these small torches called Gentech, and you gotta watch out. Gentech makes two little torches with really confusing names. One's called the compact torch, the other's called the small torch. One is Smith compatible, the other one is not. The third-party aftermarket tips work on Smith compatible. So if you're buying a Gentech and you want to use the aftermarket tips, you gotta make sure you get the Smith compatible. So there we go. Now I'm gonna put away the Bunsen. You need a more convenient valve for that thing, I think. And I'm going to give this a little bit more heat on the surface. And I'm using the Delta Mag flame not because I want a hotter flame, but because I want just a larger extent of relatively cold flame. And I'm just gonna kind of spin the surface that I think is going to be the good surface, and the edges a little bit, and just give them kind of one more, kind of the last and final, make sure everything is hot, make sure everything's fused together. Give the bubbles one more chance to pop. You gotta be real careful in this operation. That is a super, super unstable piece at the moment. Not going to apply any pressure at all to the center. Just make sure it is flat. Give it the last eyebolic examination. Look at the surface. Doesn't look that bad at all. We'll see how it cleans up in cold work. And into the kiln it goes. So that's the process, and that's it for today's video, and hopefully at least somebody might find it a little bit useful, a little bit informative. And once again, if there's anybody out there in YouTube land that has totally mastered this process and can see exactly what I'm doing wrong, Please, educate me. I love being taught. I love teachers. Nothing better than learning. Well, maybe inventing. Maybe that's better than learning. I don't know. Anyway, it's been fun. Thank you for watching.